So today we're doing Module 4, Lesson 10, and your learning goal says I can write, compare, and solve expressions. Oops, let me change it to this. Good. Expressions that have parentheses. Now, let's talk about those two words. What is an expression? What's another way to say math expression? Gia? A math sentence, a number sentence, or a math equation. Kish, can you give me an example of an expression? Maybe 1 plus 1 equals 2. Is that an expression? Sure. Kish, can you give me another expression?
2 times 4 is 8.
Oh, 2 times 4 equals 8. That's another expression. So expressions are just math sentences. And parentheses are these things. We use them in writing all the time, but we can also use them in math. And today we're going to take a look at how we use parentheses when we're writing and solving math expressions. So my whole point of reviewing this order of operations with you, which you should have learned in 4th grade, is what always comes first?
Parentheses.
Yeah, even if you can't remember the rest of PEMDAS, it starts with what letter? P. So in math, parentheses means this comes first. Do this first. So if you ever want to tell someone a series of math steps and you want them to do a certain step first, you should put it in what? Parentheses. So my big takeaway from today is parentheses means do this part first. Does that make sense? Good. Go ahead and draw this tape diagram into your notebook. The directions say to write an expression that matches this tape diagram and then solve it. To help us figure out how to write a math expression that will match this diagram, we have to describe it in words. Okay, so let's ask ourselves, how would you describe this in words? Well, whenever we have a piece of tape, I always ask you, what's the whole, right? What is the entire piece of tape worth? Well, 9 plus 11, which is 20. We can do that in our head. So it's worth 20, but that would not reflect what's here, right? We call this part, you just said 9 plus 11. But when we have this plus sign, what's the word that means plus? If I have two things added together, I found the sum. So this is the sum of what? 9 and 11. Do you agree? Now looking at what our fraction question mark here is, it's only asking us to find that part, right? So are we finding all of the sum of 9 and 11? We're actually finding what? 3/4 of the sum. So in words, I could describe this as 3/4 of the sum of 9 and 11. Do you agree? Okay. Now we know that the word, by the way, is this a math expression or is it words? So now we have to somehow translate the words into a math expression. Well, luckily for us, we already know the word of means what? Multiply. So we know we have 3/4 times something. Well, we have 3/4 times the sum of 9 and 11. How do I show the sum of 9 and 11? It's 9 plus 11. Except, if I wrote it like that, it'd be 3/4 times 9 and then plus 11. Is that what we want? We want the entire sum of 9 and 11. So, written all in black, the math expression would be 3/4 times the sum of 9 and 11. Because if a person is going to solve this problem, they would first have to find the sum of 9 and 11 and then find 3/4 of that. Does that make sense? Okay, so here is our math expression, but we didn't solve it yet because it says write an expression and then solve it. So let's solve it. In order to solve it, what do we need to do first? Add 9 and 11, which is? So really, we're finding 3/4 times 20. If I want to write that as a math expression, I can write as one fraction, 3 times 20 over 4. Do you agree? I see some similar factors because 4 and 20 are both in what fact family? 5. So this is the same thing. I'm going to write it up here. 3 times 4 times 5 all over 4. I see the similar factors, and I end up with 3 times 1 times 5 over 1, which is 15. So once again, here is the math expression, and here is how the answer should look. Once again, let's start by describing it in words. Okay, let's start with what we know here, what we have here. We have 1/3 minus 1/4. Well, this time we're not finding a sum because we're subtracting instead of adding. When I subtract, am I finding a product? Am I finding a factor? Am I finding a sum? I'm finding a difference. So just this part right here, how would we describe it in words? It's the difference between what?
1/3 and 1/4.
Good. And this, you learned this skill way back in modules 1 and 2 when we had to take math expressions and write them in words, right? Do you guys remember doing this? Okay, so if this part right here, if this section of the tape diagram is the difference between 1/3 and 1/4, is that the entire thing we're trying to find? How many copies of the difference of 1/3 and 1/4 do we need to make? 1, 2, 3, 4, 5. So this in words would be 5 times the difference between 1/3 and 1/4. Do you agree? That's in word form. Now we have to translate it to number form. Well, luckily 5 is a number. Times is what symbol? Multiply. The difference between 1/3 and 1/4. Is that going to do it?
No.
What are we missing?
The parentheses.
The parentheses are very important so that we first tell the mathematician that we need to find the difference between the two fractions before multiplying. If we didn't have the fractions there, it would be the difference between 5 copies of 1/3 and 1/4. Do you see the difference? Okay. Now we need to solve it. Well, according to our math equation, what do we need to do first? 5 times 1/3? 1/3 minus 1/4. But we can't do that because we need a LCD. What would the LCD be? So 1/3, let me erase this equal sign because this is not equal. Okay, 1/3 is equal to how many twelfths? Okay, and 1/4 is equal to how many twelfths? So what's the difference between 1/3 and 1/4? 1/12, because 4 twelfths take away 3 twelfths is 1/12. So now if I were to rewrite this, I would have 5 times 1/12. Yeah? And what is 5 times 1/12? 5/12. So the answer is 5/12, and the expression is 5 times the difference between 1/3 and 1/4. And 1. We can think of the parentheses as saying, think of this as one number. Isn't that one amount, right? And we have to find 5 times of that one amount. If we didn't have that there, 1/3 and 1/4 would be separate amounts that we would have to multiply by 5, and that's not what we're trying to tell the mathematicians to do. So in this case, if it says the product of 4 and 2, the word product means what? Multiply. So I have to do 4 times 2, but I'm dividing the entire thing by 3. Right? So again, I need these parentheses to show that I'm first finding the product of 4 and 2. Now in this case, do I really need the parentheses? No, because if moving from left to right, I would naturally do the multiplication before the division. But putting the parentheses there to be extra clear is a good idea. Now are we done? The directions tell us to write an expression. Did we write an expression? It tells us to evaluate the expression too. What does evaluate mean? Solve. So now let's solve it. 4 times 2 divided by 3. What part should we do first? The multiplication or the division? Why? Because it's in parentheses. But even if there were no parentheses there, we would do it first because it's on the left. Does that make sense? Let's do it. What's 4 times 2?
8.
Divided by 3. How can I write that as a fraction? 8 over 3. Do I have any holes there? 2 holes, and how many thirds? So the answer is 8 and 2/3, and there is your expression. You're going to box both because the directions tell us to write and evaluate. So there's 2 parts to the answer. If we're trying to figure out what side is bigger without calculating, we need to look at what we have on each side. Over here, we have 2/3 of the sum of 9 and 12. What is the sum of 9 and 12? 21. So over here, it's basically like we have 2/3 of 21. Do you agree? Over here, we have 2/3 of 15. So what's going to be bigger, 2/3 of 21 or 2/3 of 15?
2/3 of 21.
Okay, so then I would say that that's greater than. In my explanation, I would explain exactly that. I know on this side, it's 2/3 of 21, which is going to be larger than this side, which is 2/3 of 15. Did I actually tell you what 2/3 of 21 or 2/3 of 15 are? But logically, you know that the same fraction of a bigger number is going to be bigger, right? Okay?